hardly the stuff of nightmares, but appearances can be deceiving. And Paleopsilopterus had something its contemporaries lacked: potential. What set Paleopsilopterus apart was its agility and speed, traits that would become hallmarks of its descendants. While it may not have been the apex predator of its time, dwarfed by monstrous crocodilians and giant snakes, it was a harbinger of things to come. Little did the other inhabitants of ancient South America know that they were witnessing the birth of a dynasty that would reign for millions of years. As the Eocene progressed, so did the terror birds. Nature, it seemed, had plans for this lineage of avian predators, and those plans involved getting bigger, much bigger. Just 3 million years after Paleopsilopterus took its first steps, a new player entered the scene. Eleutherornis, a terror bird that stood 50% taller than its ancestor, emerged as a formidable predator. But Eleutherornis wasn't content with merely growing in size. It also expanded its range in a way that no other terror bird would match. While most of its kin would remain firmly rooted in the Americas, Eleutherornis spread its wings and ventured across the sea to Europe. Fossil remains of this globe-trotting terror have been found in both France and Switzerland, making it the only known member of its family to have lived outside the New World. But Eleutherornis was just the opening act. Studies of terror bird brain cases suggest that they had well-developed visual and auditory centers, indicating keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. 3 names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Brontornis. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 2 meters, or 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 3 meters, or 9.8 feet tall, and weighed around 250 kilograms, or 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse, and a beak that could crush bone. I have been fascinated by the terror bird's skulls ever since I first saw one reconstructed. Recent studies have shown that Kelenken and other large terror birds possessed a unique skull structure. It set them apart from their smaller relatives. This adaptation, known as the terror bird skull type, gave them increased bite force and pecking power. It makes me wonder if these giants were capable of taking down larger prey than we previously thought. Maybe even some of the megafauna that roamed South America during their reign. But even now, the title of the largest terror bird is still hotly debated, with Brontornis giving Kelenken a run for its money. While slightly shorter at 8 meters, or 9.2 feet, Brontornis was built like a feathered bulldozer, potentially weighing up to 400 kilograms or 880 pounds. This made it not just the heaviest terror bird, but also the heaviest carnivorous bird of all time, and the 4th heaviest bird overall. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleobiogeographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors that led I find myself often pondering the fate of the terror birds. It's easy to assume that placental predators simply outcompeted them into oblivion, but the fossil record tells a more complex story. Most terror birds, along with their South American rivals, had already vanished long before placental predators arrived in significant numbers. This timing discrepancy makes me wonder what else was at play. The success of Titanis in North America further complicates the competition hypothesis. Speaking of dominant animals, the big cats are a group that always captures my attention. Today, the lion may be the king of the jungle, but the tiger stands out as the largest, most powerful, and most skilled of them all. However, there was one species in particular that stood above them all. Not only did it dwarf the modern tiger in size, but it ranks among the largest cats to ever exist, the Nandong tiger. In the early 20th century, Dutch paleontologists were excavating near the village of Ninggandong on the island of Java in Indonesia, when they made a startling discovery. They unearthed a collection of bones that belonged to a tiger, but it quickly became apparent that these weren't the regular Bengal tiger bones they were used to. These were bigger than anyone in the modern world had ever seen. Further research and analysis of additional fossils revealed even more astonishing details about this strangely huge tiger. For thousands of years during the Pleistocene epoch, the Gandong tiger roamed the Sundaland region of Southeast Asia, striving to establish itself as the dominant apex predator. This formidable beast was larger than its modern-day counterparts, with adults weighing up to 20 to 25% more than the average present-day Siberian tiger. Larger males typically weighed upwards of 400 kilograms, making them close contenders for the title of largest felines ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. However, a look through history tells us something completely different. Tigers haven't always been this big. Early tigers, existing long before the Nyandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied. A smaller body size offered energy conservation and agility advantages across various terrains. So the early big cats related to tigers, such as Panthera paleocinensis, likely averaged around 70 to 120 kilos in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I've always been fascinated by the idea of apex predators, those creatures that sit at the very top of the food chain. Life at the top has its perks, certainly. But even the most fearsome hunters aren't always the biggest beasts around. Because when it comes to the predator game, size isn't everything. Yet, every so often, nature outdoes itself, creating a carnivore so perfectly adapted to hunting big game that it seems almost a creature of myth. One such creature was the Ngandong tiger. As time progressed, the tiger took the stage from the late Pliocene to the Middle Pliocene, boasting a weight range of 200 to 350 kilos. This gradual increase in size over the years, I believe, can be explained by the competition for food among large carnivores, which needed to eat more and gain more weight to compete for the apex predator position. This tiger existed from the early to the Middle Pliocene, and its remains were discovered in Tril, Indonesia. Before it, there was another tiger species weighing between 110 to 150 kg. The Ngandong tiger wasn't the only fearsome beast vying for dominance. It faced stiff competition from other carnivores like the Smilodon, giant hyena, and dire wolves. The Smilodon, for example, is known for its long, slender canines that could reach up to 12 inches, capable of inflicting deep wounds on its prey. In contrast, the Ngandong tiger possessed more typical robust canines similar to modern tigers, ideal for crushing bone and delivering powerful bites, though less specialized for deep punctures, which wasn't always effective considering the enormous size of prey then. Although, when it comes to the matter of size, it appears that they were evenly matched as the largest species of Smilodon. The Smilodon popule weighed between 220 and 436 kilos and stood 120 centimeter tall, which is not that far off from that of the Nyandong tiger. A less formidable rival for the Ngandong tiger would have been the giant short-faced hyena, which stood about 90 to 100 centimeters at the shoulder and averaged 110 kg in weight. However, a group of animals that the Ngandong would not have dared to infiltrate are the dire wolves. Although they had smaller jaws and weighed way less than the Ngandong tiger, they had a unique edge over it. And that is because they hunt in packs of more than 4 individuals. In contrast, as a solitary hunter, it would have been quite difficult for the Ngandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competitions for apex predator status. However, that was not the only thing the Ngandong tiger had to worry about when defending the apex predator title, because around this time the early humans were notably prevalent in Southeast Asia, as over 80 individual remains have been found in that region today. So it's likely that they would have crossed paths with the Ngandong tiger. It is easy to say that such encounters would have been unfavorable for the early humans, because when it comes to size, they stood very little chance against such predators. But saying that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back against the Ngandong tiger, forcing the tigers back to the open woodlands and allowing early humans to establish a foothold in the region. One thing about the open woodlands of Sunderland in the Pliocene epoch is that it had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful despite the Ngandong's enormous size. For instance, stegodons were massive proboscideans, closely related to elephants, with some species reaching immense sizes. Even smaller species of stegodons would have dwarfed the Ngandong tiger. Stegodon donsky, for instance, is estimated to have weighed around 12.7 tons. Their thick and tough skin would have protected them from bites or claws. Then, Ngandong tiger's best chance would be a scavenging opportunity or an attack on a vulnerable stegodon, like the young, injured, or isolated. Another example is the water buffaloes, known as babelis, which are renowned for their large size and formidable strength, with some species weighing over 1,000 kilograms and moving in packs. So it would have been quite hard to face a herd of water buffalo, as their massive size, strong horns, and collective defense would overpower the tiger. The Ngandong tiger's only chance against such a colossal opponent would be to exploit their limited agility and target vulnerable areas through a surprise or flank attack. However, the Ngandong tiger succeeded more with other herbivores like Rusatimorensis, Malayan tapir, giant rats, gibbons, and wild boars. Despite its many difficulties, the Ngandong tiger still earned its place as one of the most impressive predators of all time. Since it hunted alone, its smart hunting skills and ability to target weaker prey, and even sometimes scavenge, shows us how adaptable and tough the beast was. This quality made it thrive for 1,000 years until the extreme climate shifts of the Pliocene epoch. These included periods of intense cold, with vast ice sheets locking up water, leading to lower sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result of this, Sunderland was fragmented into smaller islands, leading to the isolated populations of Ngandong tigers with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, scientists proposed that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Ngandong tiger population. Other factors may have also contributed to their demise. But with limited fossil records, we are left with many unanswered questions. Imagine a cat the size of a bear, capable of leaping over a one-story building. That's the Smilodon, the saber-toothed cat extraordinaire. Not just any big cat, but the undisputed monarch of the Ice Age. The Smilodon. Its iconic saber teeth and fierce appearance are instantly recognizable. a status solidified by its portrayal in films like Ice Age. It all began in Brazil about 160 years ago, with a discovery that initially perplexed the scientific community. When the first Smilodon remains were unearthed, paleontologists didn't immediately recognize them as belonging to a cat. Their initial guess was way off the mark. Based on some isolated cheek teeth that bore an uncanny resemblance to those of modern hyenas, they dubbed this new find Hyena neogaea. However, within a couple of years, new fossils emerged. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. Foot bones, skull fragments, and those iconic canines, which seemed almost comically oversized, painted a very different picture. As the pieces fell into place, it became clear that this was no hyena. Instead, they were dealing with a completely new genus of felid, one that was not only massive in size, but also built like a prehistoric tank. This feline was far more robust than any modern cat, a true heavyweight champion of the Ice Age. In light of this revelation, a new name was in order. Thus, Smilodon populator was born. Smilodon, meaning knife tooth, and populator, roughly translating to the destroyer, or he who brings devastation. It's a fitting moniker for a predator that redefined what it meant to be lethal. With its new identity established, the scientific community dove headfirst into unraveling the Smilodon's family tree. This quest for understanding continues to this day, with researchers currently placing our knife-toothed friend in the extinct subfamily Machirodontinae. This subfamily is home to most of what we colloquially call saber-toothed tigers, though saber-toothed cats is more accurate since these ancient felines aren't closely related to modern tigers, or any living cats for that matter. In fact, their closest living relatives might be members of the Felinae subfamily, which includes our domestic kitties. Within the Machirodontinae, Smilodon found itself in an even more exclusive club, the Smilodontini, or, as some paleontologists like to call them, the dirk-toothed cats. This group is pretty exclusive, with only 5 known genera calling it home. But what Smilodontini lacks in diversity, it makes up for in star power thanks to Smilodon. As research progressed, scientists discovered that Smilodon wasn't a lone standout. It was more like a prehistoric trio with 3 distinct members, each bringing something unique to the table: Smilodon gracilis, Smilodon fatalis, and a Smilodon populator. Now, if you found yourself face to face with any of these species, you probably wouldn't be too concerned with which one was about to turn you into lunch. But they did have their differences. First up, we have Smilodon gracilis, the elder statesman of the group. This OG appeared in North America about 2.5 million years ago, descending from an even older genus called Meganterion. Next came Smilodon fatalis, strutting onto the scene roughly 1 million years later. Last, but certainly not least, Smilodon populator made its grand entrance about 600,000 years after Fatalis, fashionably late to the Ice Age party. Smilodon gracilis, while no slouch in the size department, was the runt of the litter, tipping the scales at about the same weight as a modern jaguar. Smilodon fatalis, living up to its name, was a step up in the terror department, matching an African lion in size, but packing on extra muscle like a feline bodybuilder. We're talking about 280 kilos, or 620 pounds, of prehistoric fury. That's on par with the largest tigers roaming the earth today. But Smilodon populator dominated them all. This behemoth pushed the boundaries of felid physiology, with the largest known specimens estimated to have weighed in at a jaw-dropping 470 kilos, or 1,040 pounds. To put that in perspective, that's about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to be too hung up on gender norms. Studies suggest that there wasn't a significant size difference between males and females, a trait scientists call low sexual dimorphism. In practical terms, this means that, regardless of whether you were facing a male Smilodon or a female Smilodon, you were in for equally big trouble. Now, being big is impressive, but Smilodon wasn't just large. It was built like a prehistoric tank. The Smilodon's heel bone was a marvel of natural engineering, robust and elongated. That's longer than many modern kitchen knives. Precision instruments of prehistoric destruction, shaped like deadly daggers with sharp points and smooth, narrow sides. These teeth were designed to pierce deep into flesh with devastating efficiency. And here's where things get really interesting. You'd expect a predator with teeth like that to have a powerful bite to match. But surprisingly, studies have shown that Smilodon's bite was relatively weak, about 1,000 newtons, which is 4 times weaker than a modern lion's. So, how did it kill? Well, that's been a subject of much debate among paleontologists. One popular theory suggests that Smilodon was the original ambush predator. I picture this: a Smilodon hidden in dense vegetation, waiting for the perfect moment. Then, with a powerful leap, it pounces on its unsuspecting prey. Using those muscular forelimbs and grappling hook claws, it pins down its victim. With precision, it sinks its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But not everyone buys this gut-stabbing hypothesis. Many researchers favor a different, but equally grim, scenario. They propose that Smilodon used its powerful build to quickly overpower its prey, then delivered a precise, lethal bite to the throat. This would have caused severe blood loss and suffocation, a quick, if not particularly pleasant, end for its unfortunate victims. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group, who then also got stuck. It's a grim thought, but it could explain why we find so many Smilodon remains in one place. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching, though in a prehistoric, slightly grim sense. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodons. The idea is that these injured I find myself constantly drawn back to the image of a Smilon with hip dysplasia, somehow surviving to adulthood. It's a testament to something, perhaps the surprising tenderness that can exist even in the most brutal corners of the natural world. The thought of those saber-toothed cats being cared for by their own kind, like modern lions or wolves tending to their injured, it's a surprisingly heartwarming idea. Of course, not everyone agrees with this picture of a Smiland social club. Some researchers point to the more isolated remains found outside predator traps, suggesting a lonelier existence, more in line with today's big cats. Regardless of whether they were team players or solitary hunters, one thing is certain: Smilands reigned supreme. But even at the top of the food chain, they faced stiff competition. The Ice Age was an era of giants, and Smilands weren't the only predators with an appetite for mammoth-sized meals. Two of their biggest rivals were the American lion and the dire wolf. Now, while the dire wolves of Game of Thrones might come to mind, the real ones, while impressive, weren't quite as monstrous. But they were formidable predators nonetheless. Isotope analysis reveals their diet was remarkably similar to the Smilands, meaning they were often vying for the same prey. So, how did Smilands meow up against these competitors? When it came to the American lion, it was likely a standoff. The American lion had size on its side, being one of the largest cats ever to walk the earth. But Smilands had those incredible canines, a pretty effective deterrent. My guess is that these two apex predators mostly avoided each other, but when conflicts arose, the outcome could have gone either way. The dire wolf, on the other hand, seems to have often come out second best in confrontations. Evidence from La Brea suggests that dire wolves frequently abandoned their kills when a Smiland appeared. And it's not hard to see why. Those sabers on full display would make most predators think twice. But lions and wolves weren't the only competition. The Ice Age also saw the rise of the short-faced bear, a beast that could make even a Smiland look small. Some of these bears reached dinosaurian proportions, rivaling medium-sized sauropods in weight. However, these giants were more omnivorous than Smilands, which likely reduced direct competition. Plus, bears tend to be solitary creatures. So, if a group of Smilands encountered one, the bear might have decided it wasn't worth the trouble. We've talked a lot about Smilands' hunting adaptations. But there's one question we haven't addressed. How on earth did they eat with those ridiculous teeth? After all, those saber-like fangs seem like they would have been quite the obstacle. Well, Smilands had a solution. Unlike most predators that can chomp down from the front, Smilands were equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. To eat, a Smiland would have turned its head to the side, using these carnassials to slice off manageable chunks of meat, while its saber teeth stayed out of the way. If this eating style sounds familiar, it's because many modern cats and even other predators use a similar technique when tackling tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style accordingly. With its unique adaptations and hunting prowess, Smilands carved out a vast empire. The more widely accepted theory points to the broader quaternary extinction event as the primary cause. This was a period of significant climate change that led to the disappearance of many large animal species in North and South America. As the megafauna that Smilodon relied on for food began to die out, the saber-toothed predator found itself in an increasingly precarious position. It's a cruel irony. The very adaptations that had made Smilodon such a successful hunter of large prey became a liability. Specialized to take down giants, Smilodon struggled to adapt to a world where those giants were disappearing. It was, in essence, too good at what it did, and when the world changed, it couldn't change with it. The extinction of Smilodon marked not just the end of a species, but the end of an era. It was the last of the saber-toothed cats, not just in the Americas, but worldwide. With its passing, a lineage that had dominated the planet for over 20 million years came to an end. Its legacy, however, still resonates in museum exhibits, in our imaginations, and as a reminder of the fragile balance between species and their environments. As we face our own period of rapid change, the lesson of Smilodon is clear. Survival requires adaptation. Most apex predators face a fundamental limitation. They're trapped in one environment. Lions rule the savanna, but are helpless in water. Great whites dominate the ocean, but can't set a fin on land. Even T-Rex, for all its might, was confined to dry ground, forced to watch as prey slipped into rivers and lakes beyond its reach. For over a century, paleontologists assumed that the greatest hunters were strictly terrestrial. Then, one discovery shattered that belief overnight. Its name was Spinosaurus aegyptiacus. Longer than a bus, armed with the skull of a crocodile and the body of a streamlined aquatic hunter, this was no ordinary killer. This was the nightmare that redefined what it meant to be an apex predator. A monster that could rival, and in many ways surpass, even T-Rex itself. The first thing that strikes you about Spinosaurus isn't its length. Though at 50 to 59 feet, it dwarfs even the largest T-Rex specimens. It's not even the massive sail rising from its back like some prehistoric fin. No, what truly unsettles you is how perfectly wrong everything about this creature appears, yet how devastatingly effective each bizarre feature proved to be. Start with that skull. A narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car. Yet, it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. Its toes were webbed, its legs positioned differently, its entire lower body redesigned for propulsion through water rather than speed across terrain. For anything living in those rivers, the nightmare was the same. The faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. And while most large theropods had relatively small forelimbs, Spinosaurus possessed powerful, elongated arms ending in massive claws. These weren't vestigial appendages, they were additional weapons, perfectly positioned for grabbing prey, maintaining balance in water, or delivering killing blows. The creature could literally embrace its victims to death. And then there's the sail, rising up to 7 feet above its spine. This massive dorsal fin dominated Spinosaurus's silhouette like the warning flag of death itself. Those webbed feet provided perfect stability for wading attacks no other large theropod could attempt. And the hunting scenarios become even more terrifying when you consider Spinosaurus's intelligence. Crocodiles are clever hunters, but they're still reptiles operating on instinct. Spinosaurus possessed the problem-solving capabilities of a large theropod, the same cognitive tools that made other members of its group effective pack hunters. Except this intelligence was applied to an environment where most prey had never faced anything remotely similar. Even more disturbing was how Spinosaurus turned the very act of drinking water into a death trap. Every animal in Cretaceous Africa needed to approach rivers and lakes regularly. For millions of years, this had been a calculated risk. Stay alert, drink quickly, watch for crocodiles. Suddenly, the riverbank itself became unreliable. That submerged log might be a 50-foot predator. Those ripples might not indicate current, but the approach of something that could strike from below with the force of a freight train. The fossil evidence suggests Spinosaurus didn't just occasionally venture into water. It lived there. This wasn't a terrestrial predator that sometimes waded in for a quick meal. This was a creature so perfectly adapted to aquatic life that it spent most of its time submerged, transforming ancient waterways into hunting territories more dangerous than any terrestrial predator could create. In a world where survival depended on understanding and avoiding threats, Spinosaurus represented something unprecedented. A predator that eliminated the fundamental distinction between land and water safety. It didn't just dominate two worlds. It merged them into a single inescapable killing field. And Lee, we can't talk about the perfect killing machine without mentioning its teeth. Conical, dagger-like, and built to clamp down on prey that thought the water would save them. Each one wasn't just for piercing. It was angled backward like barbed hooks, creating a living fish trap built on a terrifying principle: easy entry, impossible exit. But the teeth were just the beginning of Spinosaurus's sensory arsenal. Recent studies suggest this predator possessed pre-sensitive organs along its snout, much like modern crocodiles, but far more specialized. In murky river water, where visibility dropped to mere inches, Spinosaurus could detect the faint press waves of swimming fish from remarkable distances. Prey animals that relied on hiding in dark, sediment-filled water were essentially sitting ducks against a hunter that tracked by feel rather than sight. Every movement in the water, a fish changing direction, a turtle surfacing for air, even the subtle current disturbance created by gills extracting oxygen, registered on Spinosaurus's pres sensors like sonar pings on a submarine's display. The creature could track multiple targets simultaneously, predict their movements, and position itself for killing strikes with mechanical precision. Those massive nostrils, positioned high on the skull like a crocodile's, allowed Spinosaurus to breathe while almost fully submerged, keeping most of its body hidden beneath the surface. But the true weapon wasn't smell, it was touch. Its snout was covered in a dense network of tiny sensory pits specialized for detecting press waves and subtle water disturbances. In murky rivers where visibility dropped to inches, this system worked like underwater radar. Every flick of a fish's tail, every ripple from a struggling lungfish, even the faintest shift in current. The sails served another more practical purpose that would have terrified any creature unlucky enough to encounter Spinosaurus in shallow water. When the beast needed to move through areas where full swimming wasn't possible, that massive dorsal structure acted like the keel of a boat, providing stability and control, even in water too shallow for other large predators to navigate effectively. Spinosaurus remained a perfectly balanced killing machine. Even at 7 to 8 tons, it possessed the mass to overpower virtually any prey, yet remained streamlined enough to move through water with deadly grace. Modern great white sharks inspire fear because they embody millions of years of mastery in aquatic predation. But Spinosaurus had even longer to sharpen the same deadly craft, only with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. The result wasn't just a hunter of rivers and lakes. It was a 7-ton monster that transformed every waterway it entered into its personal killing field. I sometimes feel like I can see the world as it was millions of years ago. I can almost feel the heat, the humidity, the danger. Imagine a world where rivers dwarf the Amazon, where tropical forests stretch endlessly, and the air vibrates with the calls of creatures that make modern elephants seem small. That was the reality 100 million years ago in what is now southeastern Morocco. It wasn't the endless desert we know today, but a lush river system teeming with life. A prehistoric paradise, yes, but also, quite literally, hell on earth if you were trying to survive. This was the Kelenken Beds Formation, and every bend in the river concealed a predator beyond comprehension. In this steaming, river-choked ecosystem, Spinosaurus reigned, but it was far from alone. The Kelenken Formation reveals a deadly mix of predators, prey, and rivals, all coexisting in what might have been the most dangerous environment in Earth's history. On land, giants like Carcharodontosaurus patrolled the inland areas, while Spinosaurus dominated the waterways. Sarasuchus, the 40-foot super croc, directly competed for aquatic hunting grounds. Mid-sized hunters like Rugops cleaned up Spinosaurus's leftovers, while swift predators like Deltadroius and Bahariosaurus used speed and specialized tactics to carve out their place. Even herbivores like Ouranosaurus, Rabacchiosaurus, and the colossal Paralititan somehow managed to survive. The waters themselves were filled with monstrous prey: Entroprist, Morsonia, Kelenths, Lepidotes, and lungfish. Every species lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. Spinosaurus didn't just kill efficiently, it killed constantly. The sheer abundance of fish remains in formations where Spinosaurus fossils are found indicates a predator that was actively hunting and feeding throughout its territory. This wasn't a creature that killed when hungry and rested when satisfied, but a perpetual killing machine, transforming every waterway into an active crime scene where death could strike from any angle at any moment. Unlike terrestrial predators, Spinosaurus could use the water as a weapon. Its powerful arms and webbed feet allowed it to create underwater currents that disoriented prey, while its massive size displaced enough water to generate press waves that stunned smaller fish. Its bite force, while not matching T-Rex's record-breaking numbers, was perfectly calibrated for its intended purpose. Steady, inescapable press from backward curved teeth. The last Spinosaurus died approximately 94 million years ago. Yet, the questions this creature raises about predation, dominance, and the very limits of survival continue to ripple through scientific understanding, like press waves from some impossible prehistoric nightmare. Of course, Spinosaurus wasn't the only apex predator to ever walk the earth. When we think of prehistoric apex predators, our minds often drift to the iconic Tyrannosaurus rex or the fearsome megalodon. Yet, lurking in North America's ancient past was a predator so extraordinary it could make today's largest wolves look like lapdogs. Today's grey wolf may hold the crown as the largest living canid, reaching weights at 65 kilos or 143 lbs. But rewind to the Miocene epoch 20 to 5 million years ago, and the game changes. Meet Epochs, a colossal predator so fearsome it could rival a lioness in size, and had jaws powerful enough to outmatch a grizzly bear. In simpler terms, this was a dog that could eat a lion. Its name says it all. Epicyon, meaning more than a dog, because calling it just a dog doesn't do it justice. The story of Epochs' discovery represents one of paleontology's most intriguing progressions from misidentification to revelation. Over 160 years ago, in the fossil-rich sediments of Nebraska, scientists unearthed the first fragments of what would later be recognized as the largest canid species ever to walk the earth. The initial discovery consisted of a fragmented lower jaw, while obviously from a large carnivore provided only hints of the creature's true nature. The jaw's wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. This classification seemed logical at the time given the limited fossil evidence. However, as more complete specimens emerged from North American fossil beds throughout the following decades, a much more complex picture began to emerge. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. The skull. It was unlike anything I had ever seen. Those specialized enlarged premolars, that robust cranial structure, they reminded me more of a lion or hyena than any dog I knew. What exactly was this creature? The answer, as so often happens in paleontology, was written in the bones themselves. Those specialized premolars, that powerful jaw. They pointed to the Borophaginae, a distinct group within the larger canid family. This group, often called the bone-crushing dogs, was one of the most successful, yet strangely one of the least known, branches of the entire canid family. 66 different species, as far as we can tell. Powerful teeth, short but deep jaws, and a fifth toe, a feature lost in many modern canids, defined them. For over 15 million years, they dominated the North American landscape, evolving into an impressive array of forms. Some were no bigger than foxes, others rivaled or even exceeded the size of modern grey wolves. And then there was Epochs, the ultimate expression of this bone-crushing lineage. Its name literally translates to more than a dog. Recent studies of modern canids have really helped us understand where Epochs fits within the larger family tree. The Borophaginae, it turns out, were a highly specialized branch, one that followed a very different path than the lineage that eventually led to modern wolves and dogs. This specialization explains both Epochs' unusual features and, perhaps, its eventual extinction. Within the genus Epochs, 3 distinct species emerged, each filling its own ecological niche: Epochs saevus, Epochs haydeni, and Epochs elodontoides. They were all impressive predators, but they varied significantly in size and build. The smaller species, saevus and elodontoides, were more gracile, built for agility and speed. But even these smaller types typically weighed twice as much as a modern German Shepherd. But it was Epochs haydeni that truly pushed the boundaries of canid adaptation. Adults routinely reached lengths of almost 8 feet, rivaling a grizzly bear. They stood nearly 3 feet tall at the shoulder, about the height of a wild deer. These massive animals weighed between 220 and 276 pounds, heavier than modern leopards, comparable to large jaguars, and, intriguingly, they exhibited significant size polymorphism, variation in size among individuals of the same species. Some specimens may have reached weights of around 370 pounds. That's the weight of a medium-sized male lion, making them the heaviest canids known to have ever existed. But Epochs' size was only part of the story. Its most remarkable feature was its bite. Biomechanical studies have revealed that this ancient canid possessed one of the most powerful biting mechanisms ever seen in a mammalian carnivore. Enlarged premolars, strategically positioned canine teeth placed closer to the jaw joint than in modern canids. It all added up to a highly efficient biting apparatus. The bite force may have exceeded 16,000 newtons, comparable to a large American alligator. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips during bites. A bite that could easily pierce through thick hide, flesh, and even bone. This ability to process bone would have been especially valuable during times when food was scarce. The Miocene epoch, when these creatures lived, saw significant climate fluctuations, periods of warming and cooling, shifts between wet and dry conditions. Being able to fully use every part of a carcass, even the bones, would have been a crucial survival advantage during lean times. The success of Epochs is clear from its widespread distribution across North America during the Miocene. Fossil remains have been found in more than 10 US states and parts of southern Canada, showing they could adapt to various environments. They thrived in woodlands, savannas, grasslands, and wetlands. Discoveries of Epochs remains in cave systems and edge environments are particularly interesting. These areas where different habitat types meet suggest that Epochs was strategic in its habitat selection, preferring areas that offered both hunting and shelter. They could process various foods, which likely contributed to this ecological flexibility. While mainly meat eaters, their teeth suggest they could also handle tough plant material when needed. This dietary flexibility, along with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through different seasonal changes. The ultimate disappearance of Epochs from the fossil record has long intrigued paleontologists. Early ideas suggested that competition from newly arriving big cats led to their extinction. But this idea has largely been rejected. Many of the large cats that would have competed with Epochs, like the Smilodon, didn't appear in North America until millions of years after Epochs disappeared. Current evidence points to climate change as the main reason for Epochs' extinction. The late Miocene saw significant global cooling and increased dryness, leading to big changes in North American ecosystems. Paleobotanical studies show a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epochs' specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantages as prey species became faster and more adapted to open environments, unlike their more generalized relatives, which gave rise to modern wolves and other canids. Epochs' extreme specializations may have limited its ability to cope with these changing conditions. In the dying days of the Cretaceous period, when colossal predators like the Tyrannosaurus rex reigned supreme, creatures such as Triceratops and Hadrosaurs often bear the savage scars of T-Rex attacks. Yet, amid this world of relentless aggression, one creature's fossils remain curiously unmarked by such ferocious battles. It wasn't the tallest, fastest, or most fearsome predator. But with a body armored like a tank and a tail capable of shattering bones, this creature defied the rules of survival, made even the mighty T-Rex think twice. This was Ankylosaurus, nature's ultimate fortress, a living testament to the art of defense in an age of unyielding predators. The story of this extraordinary creature began in the early 20th century, when paleontologists working in Montana's Hell Creek Formation uncovered a collection of unusual fossils. These weren't the typical bones they were accustomed to finding. Instead, they discovered an ass. The first time I encountered the name Ankylosaurus magniventris, it struck me. Fuse lizard, they called it, a creature so fortified its very bones seemed welded together. And great belly, hinting at a physique unlike any other dinosaur. It was clear from the start. This wasn't just another fossil. It was a revelation. The story begins in 1906, with Barnum Brown of the American Museum of Natural History, sifting through the Hell Creek Formation in Montana. What he found wasn't the familiar shapes of theropods or ceratopsians, but a strange collection of bony plates, peculiar teeth, and vertebrae that spoke of something heavily armored. The tail club of the Ankylosaurus wasn't just a simple bony growth. It was a precisely engineered weapon, one of nature's most effective deterrents. A large, complex gut, teeming with symbiotic bacteria, fermenting plant material to extract every last bit of nutrition. Fossilized droppings from similar species hint at this hidden world within, where microbes played a crucial role in breaking down cellulose. I picture this creature, its broad midsection a deliberate design to house this internal ecosystem, a slow metabolism, sturdy build, and an efficient grazing strategy, all perfectly suited to its environment. But it wasn't just about what it ate. It was about how it perceived the world. The Ankylosaurus possessed a sense of smell that rivaled, or perhaps even surpassed, that of many modern reptiles and mammals. Its olfactory bulbs, unusually large for an herbivore, hint at a sophisticated ability to detect food, avoid predators, and maybe even find a mate. Advanced imaging techniques have revealed intricate nasal passages within its skull. These passages, I believe, served a dual purpose, enhancing its sense of smell and aiding in thermoregulation. The convoluted structure created a larger surface area, allowing the Ankylosaurus to cool or warm incoming air, adapting to the climate shifts of the late Cretaceous. Its vision, though perhaps not as acute as its sense of smell, still played a vital role. Eyes positioned on the sides of its massive head provided a wide field of view, allowing it to detect danger approaching from nearly any direction. Peripheral vision, combined with its heightened sense of smell, would have made it incredibly difficult for predators to catch it unaware. Even its hearing, though less directly evidenced, suggests an ability to detect low-frequency sounds. Perhaps it sensed the movements of large predators or communicated with others of its kind. I find myself wondering if it used all these senses in concert with its formidable defenses. Could it smell or hear a predator approaching, giving it just enough time to position itself defensively, presenting its armored back and tail club? The Ankylosaurus, a creature perfectly equipped to navigate its dangerous world. Its reign, like that of so many other dinosaurs, ended 66 million years ago. But its legacy lives on, a testament to the power of natural design and defense. The Cretaceous period was indeed an era of titans, producing not only the largest terrestrial predator, but also the largest land animals ever known. It was during this time, around 82 million years ago in North America, that the world saw the emergence of Dinosaurs, the largest crocodilian in Earth's history. Its name, fittingly, translates to terrible crocodile. The first clues to its existence came in the 1850s, with the discovery of massive, distinctive teeth in North Carolina. Initially, these teeth were mistaken for those of a pliosaur, a marine reptile, leading to a period of confusion among paleontologists. It was clear from the start that this was something immense. The sheer size and unique characteristics of the teeth simply didn't align with known marine reptiles. The effort to correctly identify this gigantic predator was significantly advanced by Dr. Joseph Leidy, a leading paleontologist of the 19th century. His meticulous examination and publications played a pivotal role in re-evaluating these remains. Leidy's research corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. This new classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Dinosuchus hatcheri in honor of John Bell Hatcher, a distinguished paleontologist. I remember when I first read about Dinosuchus. It struck me that here was a crocodilian that rivaled even the largest dinosaurs in size and power. Early claims suggested adults could reach almost 50 feet in length and weigh over 10 tons. And unlike other prehistoric giants whose size estimates were later reduced, Dinosuchus has held on to its colossal reputation. It's a truly awe-inspiring creature. There are 3 recognized species: Hatcheri, rugosus, and riograndensis. Dinosuchus hatcheri, found in North Carolina, was among the first identified. It offered critical insights into the genus's structure and lifestyle. Then there's Dinosuchus rugosus, primarily discovered in Montana. This species displayed a more robust build, perhaps an adaptation to different prey or environmental conditions. Finally, Dinosuchus riograndensis, uncovered in Texas, represents a lineage that grew even larger than its eastern counterparts. The more plentiful and better preserved remains of riograndensis have given us a clearer understanding of the ecological role and life habits of these giant reptiles. Paleontologists estimate that the average adult Dinosuchus measured between 26 and 33 feet in length and weighed between 2.5 and 5 tons. That's more than twice the size of a male hippo. Some individuals, of course, grew even larger. Despite the initial inflated estimates, the reality of Dinosuchus's size remains impressive. It solidifies its reputation as one of the largest crocodilians to have ever lived. Among the known specimens, the riograndensis species stands out for its impressive size. Detailed studies of these remains, found primarily in Texas, suggest that the largest individuals could reach lengths of up to 39 feet and weigh around 8.5 tons. This makes them not only the largest crocodilians ever to have lived, but also heavier than most dinosaurs, except for Tyrannosaurus rex. Paleontologist Thomas Lehman extensively examined the Dinosuchus fossils from Texas. He provided fascinating insights into the biology and growth patterns of these ancient reptiles. His research revealed that the largest specimens exhibited growth rings in their osteoderms, similar to tree rings. These rings offered valuable information about their age and growth rates. It had conical and sharp front teeth for grasping prey, and blunt, robust rear teeth designed for crushing bones. This unique dental structure allowed Dinosuchus to tackle a diverse range of prey, from large dinosaurs to hard-shelled turtles, highlighting its versatility as a formidable predator. The bite force of Dinosuchus has been a topic of considerable debate and study. It reflects one of the widest ranges in estimates for any prehistoric predator. Initial research suggested a bite force of around 18,000 newtons, a figure based on the size and structure of its skull. However, this estimate was challenged by a later study, which proposed that Dinosuchus possessed an astonishingly powerful bite force exceeding 100,000 newtons, nearly double that of Tyrannosaurus rex. This dramatic discrepancy highlights the ongoing debate within the paleontological community. Dr. Greg Erickson, leading one of the key studies on this topic, employed advanced biomechanical modeling to simulate Dinosuchus's bite mechanics. Ericsson's team found that the robust construction of Deinosuchus's skull and teeth supported the possibility of such a formidable bite force. With 22 exceptionally robust teeth designed to withstand high forces, and some specifically adapted for crushing large bones, this ancient crocodilian was well equipped to exert tremendous pres. The latest evidence leans towards the higher end of the estimated range. These rings indicate that it took around 35 years to reach full size. Despite this long maturation period, juvenile Deinosuchus were still formidable predators, sporting considerable size and powerful bites even at a young age. Adding to their fearsome nature, Deinosuchus individuals were equipped with large, thick osteoderms, bony plates, that provided substantial protection against predators and environmental hazards. These osteoderms not only served as armor, but also supported the animal's massive body, increasing its load-bearing capacity and enabling efficient movement on land despite its size. Deinosuchus was a highly successful predator, as evidenced by its extensive range, with remains found throughout the United States and northern Mexico. During its prime, the American continent was divided by the Western Interior Seaway, a shallow sea, and Deinosuchus thrived on both sides of this seaway. It inhabited diverse environments, including estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, although some believe that the marine remains could have been displaced post-mortem. The adaptability of Deinosuchus is showcased by its preference for estuaries, coastal bodies of brackish water with river or stream inlets. However, it also thrived in freshwater lakes and rivers, and was potentially present in marine environments. This magnificent creature emerged from an isolated population of cave lions, trapped south of the North American ice sheets some 340,000 years ago. The sheer size of the American lion truly sets it apart, living or extinct. On average, they were about 25% larger than today's African lions. Male American lions typically weighed between 774 and 930 pounds. Some specimens discovered in 2012 have been estimated to weigh an astounding 1,353 pounds. That's the weight of 8 adult humans. Even the largest recorded Siberian tigers rarely exceed 660 pounds. The American lion was truly the heavyweight champion. But what's particularly remarkable is that despite its enormous size, it maintained the agility and speed characteristic of big cats. It could reach speeds of over 30 miles per hour, faster than any human athlete. The hunting strategy of the American lion likely relied heavily on ambush tactics. Its robust bone structure and powerful muscles would have allowed it to quickly overwhelm large prey. Fossil evidence provides compelling insights into its hunting capabilities. The discovery of Blue Babe, a remarkably preserved steppe bison in Alaska, bears the unmistakable marks of an American lion attack. I remember seeing photos of those claw wounds, the distinctive bite patterns. It's a chilling reminder of their power. What truly set American lions apart from their contemporary rivals wasn't just their size, but their exceptional adaptability and territorial dominance. Unlike modern African lions that typically control territories of 100 to 200 square kilometers, evidence suggests that American lions commanded vastly larger ranges, some extending up to 500 square kilometers per pride. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller, but more efficient. Bone assemblages suggest groups of 4 to 6 adults working together with devastating effectiveness. Perhaps most fascinating is the evidence of their den sites discovered in caves across the American West. Some caves bearing marks of occupation spanning thousands of years. I can almost see them walking through those caves. The walls of these dens often bear deep scoring marks from claws, at a scale that dwarfs anything in the present day. Some of these marks are placed over 3 meters high on cave walls, providing tangible evidence of their incredible reaching height when standing on their hind legs. These locations have yielded another surprising discovery: collections of bones from juvenile American lions of varying ages, suggesting that, like modern lions, they had developed sophisticated parenting strategies. Unlike solitary big cats, such as tigers, American lions appear to have invested heavily in cooperative cub rearing, a social adaptation. The bite force of the American lion. It's something that stayed with me since I first read about it. To think, its bite was nearly 3 times stronger than a modern lion, 6 times more powerful than a Smilodon, an almost unbelievable 1,800 pounds per square inch. I remember reading about fossil evidence found near the La Brea tar pits in California, remains of a grey wolf. Its right femur was completely severed, not by scavenging, but by a single bite from one of these lions. The wolf actually survived, showing signs of healing, but it's a brutal testament to their power. What's truly fascinating is the suggestion of intelligence. The American lion had a notably large brain case, hinting at significant cognitive abilities. This, combined with the problem-solving skills we see in modern panther species, leads me to believe they were highly intelligent predators. It seems this intelligence extended to their awareness of natural dangers. Despite being one of the most common large carnivores of their time, their fossils are surprisingly rare in tar pit deposits, especially compared to dire wolves and Smilodons. It makes you wonder if they were simply better at recognizing and avoiding these traps, a sign of environmental awareness that distinguished them. Their range was vast, from Alaska to central Mexico, adapting to grasslands and semi-forested regions. They shared this territory with mammoths, mastodons, giant ground sloths, and, crucially, early humans. There's some suggestion that these massive cats left a lasting impression on human cultures, maybe even influencing early American art and mythology. Then, about 12,877 years ago, the American lion vanished, part of a larger extinction event that swept across North America. The timing coincides with climate changes at the end of the last ice age and the spread of human populations. It seems a combination of these factors, changing environments, dwindling prey, and increasing human press, may have ultimately led to their demise. But now, let's turn our attention to another prehistoric ruler, this one of the skies. Imagine an enormous creature soaring overhead, its massive wings casting a huge shadow. A chaotic frenzy erupts below as potential prey desperately seeks a place to hide. This is Quetzalcoatlus. I find it fascinating that Quetzalcoatlus, despite its size, possessed an extraordinary metabolism. It needed that to support its demanding way of life, a metabolism that showed some resemblance to other pterosaurs. For a long time, scientists believed it was cold-blooded, like other reptiles. But now we know Quetzalcoatlus was, in fact, warm-blooded and quite active. Warm-blooded or cold, I think most would agree that Quetzalcoatlus wasn't exactly a beauty. And contrary to some beliefs, it's unlikely that any modern flyers are direct descendants of this animal. Quetzalcoatlus had a long, pointed beak, quite similar to a modern stork, but without the hooked tip. Quetzalcoatlus and other Ajdarshids have hind limb proportions more similar to modern running ungulate mammals than to their smaller cousins, implying that they were uniquely suited to a terrestrial lifestyle, even though, like other pterosaurs, they were quadrupeds when on the ground. This has led scientists to study the lifestyle and feeding habits of Quetzalcoatlus more closely. It's widely accepted that this flying giant was a carnivore, though exactly what it ate is still unclear, and there have been many speculations. Douglas Lawson, the scientist who first discovered Quetzalcoatlus, described it as scavenging on the carcasses of titanosaur sauropods, much like a marabou stork. This idea of scavenging was initially appealing because the fossil was located pretty far from the coast, and there were no signs of large rivers or deep lakes nearby when it was alive. However, the scavenging idea was largely debunked in 1996. Scientists noted that, in contrast to the hooked beaks of specialist scavenger birds, the lower jaw of Quetzalcoatlus bent so steeply downward that even when it closed entirely, a space of more than 2 inches remained between it and the upper jaw. They proposed that Quetzalcoatlus ate like modern skimmers, cleaving the waves with its beak and grabbing fish in mid-air, thanks to its long neck vertebrae and toothless jaws. Though this idea of skim feeding gained widespread acceptance for a time, it was not rigorously tested scientifically until 2007. These enormous landscapes supported a diverse range of life, offering ample opportunities for these giant pterosaurs to thrive. The idea of encountering a Quetzalcoatlus, a creature of such immense size, fills me with a certain gratitude for living in a time beyond its reign. I can't help but think about what it must have been like to share the world with such giants. It seems that Quetzalcoatlus northropi, unlike its relative Lawson, was likely a solitary hunter, roaming freely in the inlands. Lawson, on the other hand, may have lived in swarms near alkaline lakes, suggesting a more sociable nature, almost like a flock of waiting birds. And Quetzalcoatlus wasn't the only giant of its time. Fossils suggest that creatures similar to the Tyrannosaurus and Torosaurus may have coexisted with it, though more research is needed to confirm this. Imagine Quetzalcoatlus crossing paths with the Alamosaurus, or even facing off against predators like the mighty T-Rex, Dromaeosaurus, Triceratops, Albertosaurus, Edmontosaurus, and Dakotaraptor. Up in the skies, Quetzalcoatlus likely shared its domain with other pterosaurs, like Pteranodon and Nyctosaurus, all coexisting within those long-vanished ecosystems.